Alright guys, welcome back to section 6.2, General Probability Rules and Venn Diagrams. Okay, so today we're going to start out with some symbols, because you know we love symbols in math, because we're lazy. So this symbol right here that looks like a U is called the union symbol. The one right here in the middle, and that means or. So this or this, that symbol will be between it. This is called the intersection, so it looks like an N. It's called the intersection. It means and this happens. And all of you know what the empty set looks like. It looks like the no solution. And an exponent of C means not. So not A. So it's like it's called the complement. So when you see the C, it's called the complement. Okay, so we have 4 rules here. Sorry, we're still recording in my house, so you're going to hear the world going on. So the probability of any event is a number between 0 and 1. So if it's automatically definitely going to happen, that's a 1. So it's kind of like doing percentages, so like 100%, but in decimal form. So if it's 50% chance, that's 0.50. So 100%, when you move it 2 decimal places, will be a 1. So it's just like doing percentages, but in decimal form. Okay? All possible outcomes together have probabilities whose sum is 1. So if you add up all the probabilities for a whole thing together, they have to total 1. It's kind of like a pie chart. All your percentages have to add up to be 100%. Same thing there. So you would say the probability of any sample or any situation would be 1. All right. Then we have the complement rule. The probability that an event does not occur is 1 minus the probability that the event does occur. Or if you want it in symbol form, the probability of not A equals 1 minus the probability of A. So let's say the probability of A happening is 20% or 0.20. Then what's the probability of it not being A? Well, it's everything that's not 20%. So that'd be 80%. So it'd be 0.80. So how'd you do that? You did 100 minus 20. Same thing here. You do 1 minus 0.2, which gives you 0.8. That's kind of like a does statement. All right, then we have the addition rule. That says the probability of A or B is the probability of A plus the probability of B, subtract any overlap. So if you think back to like Venn diagrams and things like that, if you have A, you have B, and then you have where they overlap, you have to take that overlap out. Okay, so this will make more sense as we go into it. All right, so if we have just one event, what's the probability of it being A? Okay, so the probability of it being A is 0.4. The probability of it not being A, so if 0.4 is being A, then what would be the rest of it? Well, 1 minus 0.4, which is 0.6. Okay, so it would be, here we would write 0.6, because this is not A, so 1 minus 0.4. Okay, so the probability of it being A and not A, you can't be both. You're either one or the other. You can't be both. Okay, you can't be that at the same time. So this is going to be, it does not exist, or an empty set. Okay, so probability A and not A at the same time. Then the probability of A or not A. Okay, so when it says or, we're going to put those two together. So here we go. So we're going to add A and not A together. And there is no overlap because it's just one event. So the probability of A plus the probability of not A. So that'd be 0.4 plus 0.6, which adds up to be 1, because those are the only two options you got, A and not A. Now, mutually exclusive disjointed means they have no outcomes in common. So this is when you have two events going on. And so can never occur together. Okay. When they're disjointed, that means they're not connected. Okay. So here we go. See how these two events are not connected? Okay, there's no overlap there. So we have 0.3 probability it's going to be A, 0.4 probability it's going to be B. So what's the probability it's not going to be either? So let's go ahead and do that. So we do 1 minus 0.3 minus 0.4. So together they're 0.7. So that leaves me with 0.3. Okay, so now we're ready. We've got everything filled in, so we're ready to go. What's the probability it's going to be A? Well, that's 0.3. Probability is going to be B. Well, that's 0.4. Probability it's not going to be B, so you take the 0.4 out. So what do you have left? So that's 3 and 3, which is 6. So we put, if you want to put little notes over here, not B, so 1 minus 0.4. Alright, then what's the probability that it's A and B? A and B have no overlap. So this one does not exist. Okay. All right. Probability of A or B. Okay. So this is A or B. So we do 0.3 plus 0.4, and we don't have any overlap, so we don't have to subtract it off. So that's going to be 0.7. Okay. Then it says not A and not B. So that means what's left. So that's the 0.3. So we're going to put a note here, not A and not B. So that's 1 minus the 0.3 minus the 0.4. Okay, these are easy peasy. Okay, this one's a little trickier. Okay, non-mutually exclusive. There is overlap that must be considered. Okay, so I have two events. Getting into Harvard. Now let this be Harvard. We're going to let this be Yale. Okay, so now it says when you have these two things where there's overlap, start with the intersection. So the intersection's 0.3. Okay, the intersection's 0.3. The probability of getting into Harvard is 0.7. So out of this whole circle, the whole circle is 0.7. So we've already used 0.3 of it. So I'm going to make a note over here for Harvard. You have to take the 0.3 overlap. I'm going to underline that because that was really important. Out of 0.7. So when I take the 0.3 out of the 0.7, 7 minus 3 is 4. So that's what I have there. Now for Yale, it's 0.5. Same thing has to happen. This whole circle is 0.5, so I've got 0.3 of it. So that means I have 0.2 left. So I take 0.3 overlap out of 0.5. Now, this adds up, and I get 4 and 3 is 7, 8, 9. So I'm going to do 1 minus 0.4 minus 0.3 minus 0.2, and that gives me the 0.1. Okay, so now, what's the probability of getting into Harvard or Yale? Okay, so with this has overlapped. Okay, get into Harvard or Yale, not both. Okay, so you could do 4 plus 2, or you could do the 0.7 plus the 0.5 minus the 0.3. That gives me 0.9 right there. Okay, I couldn't do the 0.4 and 0.2. Sorry. because I'd be subtracting 3 off twice. Sorry about that. So you take the 0.7 probability of Harvard, probability of Yale, minus the overlap. Okay, so the next one is not Harvard, not Yale. Okay, so that means you're looking at this piece out here. So you're going to take off the 1 minus the 0.4 minus the 0.3 minus the 0.2. And that's going to give you 0.1. The next one, so we're going to get into Harvard and not Yale. So the part of Harvard that's not connected to Yale is the 0.4. And then this last one, not Harvard, but Yale. Okay, so that means it's the Yale piece that does not have the Harvard. And actually, technically, I should have written it differently. Let me write that differently because we don't have a but in there. Yale and not Harvard. So that would be the 0.2. Okay, and that's all for today. If you have any questions, please feel free to reach out, and have a great day.